This is a quick talk on just Ceph from a Gentoo developer's perspective. I'm a Gentoo developer. I'm a staff release engineer at the Future Technology Group at Sony Interactive Entertainment. I work with Jason, who gave a talk this morning. I've also been a Gentoo developer since 2006, and I've been maintaining the Ceph package on Gentoo since 2015. And at SIE, we're using Ceph in multiple production environments. You can take a look at Jason's talk if you want a little bit more information about our usage of Ceph. So I'll do a little bit about Gentoo. Gentoo is kind of a toolkit that you can build your own distro. Packages are generally built from source rather than pre-built, so you're not, when you install it, it actually goes and compiles everything on your machine by default. There are such a thing as binary packages, and you can use them sort of in a production environment. You pre-build them on some build machines, and then you deploy the binary packages. The e-builds are package specification. They're written in basically it's a DSL based on bash, so it executes in bash, and while it's installing, it's bash functions that are running, but there's a lot of helpers, and there's some libraries that you can use to share code across a bunch of e-builds. So like e-builds are built with CMake. Instead of having a lot of boilerplate in every single one, there's a CMake e-class. And there's a Python e-class instead of a lot of boilerplate in every single package. And that also allows, like, if something changes upstream or you find a bug, you don't have to go and update every package that uses Python. You can just update the e-class, and then that fix applies to every single package. It's kind of useful. When the packages are built, they get installed to a staging area before being merged into the system. All compilation is done in a sandbox. So the build system does not have write access to the file system that it's running on. It only has write access within the sandbox. And there's no network access whatsoever. Everything that's needed during the build process has to be pre-downloaded based on a set of predefined, essentially it's tarballs. It can pre-download it uses URIs, and it has to pre-download like tarballs. There are some ways to do Git, but generally those are only what's called live packages, because we don't want the possibility of the code changing between when the developer tests the package and when some user installs it. So if you're doing a Git checkout, if something changed upstream, then it goes and downloads the latest master or main, whichever repository you want to call it. Then you might get something different, and then you don't know what your user's running, and it's kind of hard to reproduce bugs. And also, this is kind of unique these days around Linux distros. It supports systemd and OpenRC. OpenRC it's actually been around longer than systemd. It's an init system that does use shell. You can have a init script written in shell, though it does also use the declarative style init, where you can just set some variables, and it can handle everything automatically, and it does have dependencies. So you can have this service needs to run after this service, or don't run this service if this service doesn't run. At SIE currently, we're using OpenRC, although we may, for Ceph specifically, be using systemd in the future. Not sure yet. So the Ceph Build system. So I've been the packager for Ceph for quite some time, and the Ceph Build system it has been getting better for packagers, but there are some things about the build system that are a little bit suboptimal from a packager's perspective. Now, in general, Ceph is pretty good, but it is a very complex package with a lot of dependencies and a lot going on. So it is a complicated package, piece of software to package. One of the first things is there's quite a bit of configuration available in the build system. So what I'm showing here is sort of a section. This is just a snippet of the e-build of the configuration section. Gentoo has something called use flags that allows you to expose options, compile time configurable options to the user, so you can switch them on and off. Ceph has quite a few of these, And you can change things as fundamental as a memory allocator. It does make it difficult to test sometimes, where we just basically have to let the users do a lot of the testing because I can't possibly test every single possible combination. And I have had instances in the past where less common combinations just fail to build. There were a few versions a while back that if you disabled RGW, if you didn't build RGW, the entire thing wouldn't build, which is unfortunate. So one pain point that's kind of ongoing for me is I mentioned that the eBuild's built in a sandbox environment with no network access. Well, the Ceph Build system creates some virtual EMs and then runs pip install in them halfway through the build. This doesn't work. So this is a patch that I apply. This is against the current version of Ceph. I don't remember the code name, I just remember the version number of 17.2.5, and it just rips out the virtual env. And I have to update this patch quite regularly because the code changes, and the approach I use in the eBuild for handling what's installing is I just have that as a dependency that gets pre-installed. And then they're just there, so it just works. Another place is with System Boost. So the library bundled with Ceph, all of the compilation commands are linking against the Boost library with Boost : and in the library. Where system install Boost packages on Gentoo and Ubuntu as well, the Boost libraries are Boost _ rather than Boost : and this makes it not build. And I had been maintaining a patch that I had to update with every single minor, like micro bug fix release to fix this. And I believe around Ceph 16, I finally came up with this that goes across the entire build system and changes Boost : to Boost _, and that's been the same ever since. But it would be kind of nice if I didn't have to set the entire build system to use a System Boost. If with System Boost actually updated some variable to make it use the more common _ naming, because a lot of packages don't use the : naming for system install just because that creates, some compilers don't like it, and it just creates some issues. So this is the Patchset that I apply to Ceph currently as of 17.2.5. A lot of it is just like I've shown the virtual env patch. Another one is C flags. So Ceph and its dependencies like to just decide what compilation flags are going to use and what optimization flags. Now there's a policy in Gentoo that the users can set their compilation, like optimization levels and stuff, and the policy says that unless there's a good reason set by upstream, we should respect the user's options. So I have to patch out that and then pull in the users into the build system, and then basically tell the build system to just read the environment variable. And I mean, I'm not going to go through all of the patches now. If people want explanation as to what some of these patches do, we can go later. I probably have to look at some of them because I've been applying some of these patches. I mean, one of the patches has been since Ceph 12, so some of them have been around quite a while. So as I mentioned, Ceph is a large package with a lot of dependencies. Currently, the Ceph build has over 130 dependencies, and between releases, there's quite a bit of churn. When I'm updating to a new Ceph version, usually trying to figure out what actually changed is a little bit of a chore. Currently, what I've been doing is the first thing I do, first pass, is I go over the Debian package, and I get to sort through about 20 pages of diffs like this to try and figure out what actually changed. And sometimes there's a lot of noise in there, and sometimes it's useful. I also end up sometimes looking at the diffs in the build system, all the CMake files, and sometimes it just boils down to trial and error. Another thing about dependencies is sometimes Ceph can be a little slow to change when one of the dependencies makes a breaking API change. So sometimes new versions of Boost cause breakage, and a current one that's been ongoing since the release of Ceph 17, right around the same time as Ceph 17, one library called libfmt released a new version that had an API breakage. And I've basically just been having to force the old version because that hasn't been updated. So in Gentoo, unlike most Linux distributions, you can have multiple Python versions installed on the same machine at the same time. So this is kind of a snippet of what it would look like when you're asking it to install a package. The Python targets is telling you what versions of Python this package in the package supports. And currently the Ceph Build system is not really designed to support this very well. What I have to do, this is a snippet from the eBuild, it's in the eBuild DSL. What I have to do is I basically have to build Ceph and then make a copy of the built Ceph source tree for every Python version, and then cycle over every Python version and rebuild Ceph, or rebuild the Python bindings for that Python version, rerunning the configure and then rebuilding it. If I specifically say Python modules, it does only rebuild the modules, but I do have to make a copy of the entire source tree for each, or the entire build tree for each Python release, which is a little bit suboptimal, and it does make it so that you need quite a bit of free disk space to build Ceph, which is not necessarily an issue for corporations that are using a build server, but if someone's setting up Ceph at home on Gentoo on Raspberry Pis or something, they may not have necessarily the several gigabytes of free space needed. And so yeah, this was timed as a fairly quick talk because I only put in a 25-minute slot, so we have a little bit of time for any questions, if anyone has questions. No questions? Yep. The question was, is there any luck upstreaming any of those changes? The changes that I have upstreamed in the past, I did get them in. Usually they don't come in until the next major release. Getting a change into a bug fix release seems to be a little bit more difficult. And a lot of the changes, like as you saw with the virtual env, that was not a proper fix. That was just hacking out the stuff that breaks. So I could potentially try to rework it. My CMake knowledge is not amazing. I'm not a CMake expert. I just kind of know enough to do what needs to be done. But I could potentially look into, for example, without virtual envs or something like that, instead of doing that hack job, which I fully admit was a hatchet job on the build system. And some of them, same with the C flags changes, they're just basically, instead of having C flags, I just do a read the environment variable. But potentially, I could try to upstream them, although it is not an easy way to upstream patches and stuff. I mean, I can put them in a ticket, but then, like, I might get some attention on the ticket, or it might just get closed by a project manager because it hasn't had any activity in a year. I haven't done a pull request recently. Most of the changes I've done, I did like a Civet web tracker ticket with a patch attached. Okay. Yeah, that didn't work in the past. But, okay. I can open a few pull requests. Obviously, some of the changes are going to have to be cleaned up a little bit and made it, because I don't really want to break developers' machines. I fully understand why they're doing the virtual env and stuff like that. It just makes it easier for a Ceph developer. If you're just trying to get it running on a machine, it's easier if it can just go and download everything it needs off the internet. But that's not ideal for for a packaging use case.
I love your modesty, saying you're not the expert, and then you go and build it on Gentoo. So this was awesome. Thank you for sharing.
Welcome.
Okay, thank you very much.